In this video, we'll do the integral of x to the negative x from 0 to 1. So x can be rewritten as e to the ln x. If we raise both sides to the minus x, we can multiply the powers, so this will be e to the minus x times ln x. And e to the z is the sum, as n goes from 0 to infinity, of z to the n over n factorial. So this will just be the sum, from n goes from 0 to infinity. Instead of z, we have negative x ln x. This will be negative 1 to the n, x to the n, ln of x, all raised to the n, over n factorial. So now we want to integrate this. This will be the sum. We can move the integral into the sum. The negative 1 to the n over n factorial we can take out. And we are left with the integral. And we have from 0 to 1 of x to the n times ln x, all raised to the n dx. Like before, we're going to let u be negative ln x. That means x is e to the minus u, or dx is e to the minus u du, but we have to multiply by the derivative of the inside, which is negative 1. So let's plug all the stuff in. So this will be the sum, from n goes from 0 to infinity, negative 1 to the n over n factorial. When x is 0 plus, ln of 0 plus is negative infinity, so negative times negative infinity is positive infinity, and ln of 1 is 0. And then x to the n can be rewritten as e to the minus u to the n, so this will be e to the minus nu. Ln x is negative u, so we have negative 1 to the n, and then we have u to the n, and dx will be another negative, and then we have e to the minus u du. This integral and the negative can combine to redo the bounds to be opposite, so this negative 1 to the n and this negative 1 to the n will cancel because that's negative 1 to the 2n, so we don't have to rewrite it again. So this will just be 1 over n factorial integral from, we're going to switch the order, so this will be 0 to infinity. We're going to factor out negative u, so we're going to left with n plus 1, and then we have u to the n du. So this term comes from this and this combining. So now we're going to have a simple substitution, let z, and I forgot the u right here. Yep. Z equals n plus 1 times u. So u is z over n plus 1. That means that du is dz over n plus 1 because n plus 1 is a constant. So let's substitute that. So this will be the sum from n goes from 0 to infinity. 1 over n factorial integral. So in this case, when u is 0, n is positive or 0, so z will be 0. And then infinity will be the same thing. So we'll have e to the minus z, right? N plus 1 times u is z. And then u is z over n. So this will be z over n plus 1. But we're raising it to the n. So this will be z to the n over n plus 1 to the n. And then du is dz over n plus 1 again, so we're going to combine it with this one. So now we can factor that out. So this will be the sum from n goes from 0 to infinity, 1 over n factorial times n plus 1 to the n plus 1. It's the integral from 0 to infinity, e to the negative z times z to the n dz. But this is just n factorial, so equals n factorial, definition-wise. So this n factorial and this n factorial will cancel, so all this will cancel, leaving us with, and then I'm going to move the n to be n plus 1, so this will be n equals 1 to infinity of 1 over n to the n. So this is the answer to the integral, and that's the end of the video.